friends, welcome to my new video. So today we'll see how you can create a LangGraph agent which will be work as a MCP client. So in my last video we had seen how to create a MCP server. We have created a MCP server by using Python and we have connected to that MCP server from the Cloud desktops. So there we have used Cloud desktop as a MCP client, right? So if you have not seen that video, so I'll request, I will give the link in my description. Then please check it out. So MCP, as we all know, like MCP stands for Model Context and Protocol. It's a kind of API layer for your AI applications, right? Where you can use the external data or external data sources or any tools from your AI applications, right? So then LangGraph is a framework which build stateful multi-actor applications with LLMs. So what does it mean? So when you create a applications with LLMs, right? LLMs are pretty straightforward. You give a request and based on that model's intelligence, it will give an answers. But the applications are complex. When you create a AI applications, it is complex, right? It can follow a complex workflow in order to create certain answers or create certain tasks. Okay, so LangGraph is basically used for that. And here we'll be using a adapter called LangChain MCP adapter, which will work as a bridge between our LangGraph applications and the MCP server we had created earlier, right? This is the LangGraph workflow we are going to follow while we create these applications. We'll take users input, then we'll put it in a state variable. The state is a list variable where we'll keep all the messages, the user messages, the tool messages, and the AI messages, right? Then the messages will go to that agent node. The agent will have LLM. So LLM is a brain for the agent. So through which it will think what action needs to be performed. So when any message come from the input layer, it will think by using the LLM. It will decide whether I need to do a tool calling or I need to give a plain answer to my client, right, to my users, right? So if the LLM decide so this particular request or input require a tool calling, then it will send the request to the MCP tool, right? The MCP tool will have all the required tools. It will execute that tool, and whatever response come from the tool, it will keep in a tool message. Then it's sent to the agent. Then the agent will finally, validate and create a final answer, and it will send to the users. So in this demo, we'll create a LangGraph application. So I'm created a file called MCP underscore client .py. So we'll create a LangGraph workflow where there will be two nodes. One is the agent node and the tool node, and definitely the start and end node will be there. The agent node will work as a MCP client, MCP client for us. The tool node will connect to the MCP servers and execute our MCP tools, right? So we'll have a conditional workflow in the agent node. If the agent decide I need a tool calling for this input, then it will go to the tool node and get the answer from the tool node, then get a final answer, then go to the end node. So this is a simple workflow we'll create, and we'll use that MCP servers we have created in our last video. We'll connect to those tools, right? So first I will import the required packages. So I import these classes. Then I load the environment variable because I have kept the LLM API key in my environment variable. So I've loaded that. So this is the agent state where I've kept one object called messages. The messages object contain a list which carry all the messages of my applications, starting from the user messages, tool messages, and the AI messages as well. Then I've created this function which basically connect the MCP server informations and return all the tools available in those MCP servers. Then create an object called client, which is of multi-server MCP client. and I call the method of get tools, which basically uh, fetch all the tools of my registered MCP servers and return it in this function. Then I have created a function for creating this LangGraph workflow or LangGraph agent. So I named this method as create MCP agent. So the MCP agent uses LLM. LLM is the brain for this agent, so that it can, it can think which tools I need to use. Then if you see, so two node I have created. One node is this tool node. Another one is this agent node. And the tool node is calling this MCP tool function, which return all the tools registered in our MCP server JSON. Then also we have used a function called bind tool, right? So this basically connect my LLM with this tool so that my LLM can decide which tools I need to use. Then in my agent node, if you see, I'm reading this message objects, and here for my user input, I'm calling this function called LLM with tool, LLM with tools, which basically provide me whether I need a tool calling or not. So if my request recorded tool calling, so it provide is enter to these functions, and I've given a prompt like for this input, the user is requesting this tool. Then I am executing the tool and returning this tool result, and which is basically appended in the message object. So this is the code of my agent node. So now I'm getting the workflow. So I've created a graph where I have added the agent node, which is calling to the agent node functions. And if the tool node is there, then I also add a node called tools, which is calling this tool node function, and the entry point I have set as agent. And then there will be a conditional flow, like from agent, I should either go to the tools node or to the end node. So that again decide by this function called should continue. So I am keeping that function also should continue. So it reads like whether if the my last message has a tool calling property, so it will go to the continue. Otherwise, it go to the end node. Then I also add a edge from tools to my agent and my agent to node. Then I compile the entire workflow and return the workflow to my main function. Now, create a main function as well. So this is my main function, which which is calling to my LangGraph agent. Then I'm taking the user input and I append the user input in the message object in my state variable. Then I invoke my LangGraph agent, and I you know then I store the result information in the result state, and I update the state variable as well. Now this code block I have written to so the last messages which is coming from my LangGraph workflow. So I'm taking the last message because I don't want to return the tool messages. Okay, so I need whatever the final response I got, I need to print that. I've added some logic. So this is my code. Let me run this application. Python MCP py. So it's initializing my LangGraph agent with MCP integrations. Good. Yeah. Connected to MCP Server. Found one tools, which is analyze project lines of code LOC. We have created in our last demo. Reads all code files in the specified project and creates an Excel report showing files wise lines of code LOC. So it read the description we have mentioned in our tool. Agent is ready. Type your questions below. So I'm writing do a code scanning, of my agentic project. So my project name is agentic. Yeah, my project name is agentic. So here I need my agent or my LangGraph agent should do a code scanning of all the code files and create a Excel report for me by containing the lines of code of each file. The code scanning of agentic project. So tool requested analyze project LOC, and also argument it pass the project name is equal to agentic. So here successfully the LangGraph workflow is executed, and this is my final response. And this is the agent has created a final response based on the LangGraph's workflows outputs. The code scanning of the agentic project has been completed successfully. The report detailing the line of code has been generated and available at the following locations. This is the locations set. Okay. So here the Excel file is created. If I open that, yeah, I can see the lines of code of each files. That means my LangGraph agent is working properly and also successfully identifying which MCP tools I need to execute and perform the task, right? So this was a small demo. Thank you for watching. Let's meet in another video.